Welcome back to another tutorial. Today we're going to go over the looping nodes and logics. The two nodes we'll be covering are the for node and the while node. I don't really have a setup plan to showcase these off that I've built ahead of time, so I'll be learning them in real time. Let's get going. I'm going to put it into SmoothPOV where I can show you the nodes we'll be covering again, so for and while. But I want to show you how to find them in the node browser. So let's equip our logics tooltip. And we can open up the node browser here and we can go to flow. And then once we're inside flow, it's for, F for for, and W for while down here. Nodes are listed alphabetically, so rather than trying to find them manually, I just think alphabetically and find the nearest alphabetical letter to the one I'm looking for, and then it usually jumps out at me. Let's start with the for node, as it's the more commonly one, or at least the one that I use more commonly in logics. So for resembles and runs a lot like for does in various other programming languages such as C#, Java, JavaScript, etc., where it runs a certain set of operations for a number of operations, or a number of counts. To illustrate that, I'm going to talk about the inputs and outputs of the for node. So the for node has two inputs, which is run. So if we put our tip in here, hold trigger, push secondary, we get a pulse node, and count. Put the tip in, primary, secondary, and we get the count. So what this means is when I hit pulse, it will run the outputs, we'll talk about those in just a second, this number of times. So right now this is set to 0, but we could set it to 3. And what this would mean is that this loop would run 3 times. So now the outputs are loop start, which happens when the loop starts. Loop iteration, which you'll get an impulse on every time the loop runs through. So if this is set to 3, you'll get 3 impulses coming out of here. And loop end, which is fired once the loop has finished. So you'll get 1 on here, 1 on here, and 3 on here. If we hit pulse now, you'll see that this happens. We get 1, 3, and 1. Now, additionally, there is an output, which is an iteration. This indicates the numeric value of the iteration that we're on when you run the for loop node. This starts at 0, so the first iteration will be 0. Computers start at 0, you just have to kind of get used to that. Some nodes won't start at 0, this one does. Whatever. Take a look at it if you aren't sure which one it is, 0 index or 1 index based. So this is the for node. And that's how it works. Let's see if we can make a practical example for it. I always use sounds when I'm doing practical examples. The reason behind that is like sounds are very tactile and easy to understand. So let's go ahead and do that. So I'm going to go to audio. I'm going to go to play one shot. And then I'm going to spawn a play one shot node in the world. Then I'm going to connect the loop iteration to the top of the play one shot and delete all the other display nodes here. So what we're going to get is a sound which plays for each iteration of the loop. I'm going to go into my inventory here and go to inventory, Neos Essentials, where are we? Sound effects, UI, and then let's look for something short. I got button press here, I think. Let me just double check that my audio is turned on for you guys so you can hear that. It is? Cool. And so we're going to plug this into the play one shot. So here I'm going to open up the node browser, go to audio, audio clip input, spawn that in the world, connect that to the second part of play one shot, drag this sound, put it through the audio clip and let go, and then that will set this up. So now when I hit pulse, you should hear this click sound 3 times. They all went at once though. And that I was actually expecting, and it's useful because that shows what happens. The for node runs incredibly fast, and it doesn't wait for the end of an iteration to run another one. What I mean by that is, like, if there's some interaction that has effects that have longer than this, so this sound effect is less than a second long, but it's still, more than a couple of milliseconds. So you need to keep that in mind when you're using the for node. It runs very, very fast, and so you need to factor that in when you're writing logics for it. Like, don't have any sort of waiting or expect that it will wait until the loop is finished. It will run this impulse, and when this impulse reaches the end, it will just carry on going. Interestingly enough, I'm not quite sure, but we'll test it. What happens when I use play one shot and wait? So I can just plug this in. Play one shot and wait will wait for the sound to clip to finish before it finishes itself. I'm not sure how Logix responds to this. Let's take a look. Again, it ran all 3 loops simultaneously, so that doesn't have an effect. Cool, I didn't know that. I was just, showing. So that's playing a sound. As you can see here, we didn't have much success because it just played all sounds at once. Let's see what else we can do to just illustrate how the loop works. I think a right loop might actually help here. So this is a common sort of example that you might see, which is where we kind of, process a string using a for loop. So we've got a right node here from actions right, and I'm going to go to variables storage and get a string node here. And I'm going to connect again loop iteration to the right and target to string, pull out a display node here, and then we've got a sort of write set up. Now I need to decide what we want to write. Let's say we're going to write, guess let's just write a single character. That'll be good. So to write a single character, I'll need a string input. We'll put A. I'll need the plus node, because what we want to do is add on that A to the end of the string here. So we need to do the current contents of string plus A, and write that in each loop. So now let's hit pulse, and you'll see that we get 3 A's here. If I change this to be 2, we'll now see that we have a total of 5, because I don't reset the string between loops. But there you go. For loop is useful for doing things that need to happen on a certain number of objects or a certain number of times. String manipulation, all sorts of stuff are great like that. I think there's enough examples. I can think of many more. If you have any specific questions on how to use the for loop node, do let me know. I'll go over it in some more detail, but that should give you a good idea of how it works. I've been butchering on long enough about it. Let's move along to the while node. The while node is a little bit puzzling to think about, because whiles usually end up in a complete mess when you do them wrongly. So the while node again has 2 inputs. This time it has run, which is the same as the previous loop node, and that has condition, which can be a boolean of false or true. On the output here, you'll see it says loop start, which again runs on start, loop iteration, which will run each time there's an iteration, and loop end, which will run when there is a loop that's stopped. So if I hit pulse here, you'll see that we get a start and an end completely, and that's because the condition is set to false. While will only actually output iterations while this condition here is true. So if I change this to true and I hit pulse, you'll see that I lag. I'm not actually sure what that's going to show on the recording, because I just ran an infinite loop, basically. Give it a second to chill out for a bit. It really didn't like that. There we go. That's what happens there. I debated on including this in the video and then decided I would, because it shows what happens when Logix exceeds its sort of iteration count. When Neos detects that a Logix node or a Logix setup is running too fast, it will make those nodes red. So you can see here that the while is red and that the pulse is red here, and it's saying like, look, here's a problem with your Logix. It needs fixing. To fix this temporarily, you can just grab the node and tap secondary, which will change the node back to white and allow it to run again. But what that really means is like, hey dude, you screwed up. Like you need to change something about your Logix to make it not run like that. That's totally valid, because what I basically told Logix to do is, hey, run a impulse infinitely for the rest of time. You can actually see here that we got another impulse when we started the loop. That's why it says 2, because we ran this node twice. We didn't even get an impulse when it ended, because the node crashed, basically. But we got 39,692 impulses out of here before Neos went, whoa, Logix, that's enough. That's enough. You need to stop. So what can we use while for? So while can be used for an operation where the condition changes between iterations. So a good example here would be some process that comes off of this node which changes an incoming value. Let's set up something so you can see how it works. So I'm going to go ahead and go to variables storage int. No, that's int 2. Int. And then we need to make a condition. Condition is part of sort of regular Logix to get used to. It's basically any of the nodes which output a boolean. So in this case, we're going to use greater than. I know we want less than because it's while true, which is the opposite of what I wanted here. So we use less than here. And so we'll say if int is less than 5, this will be true. So right now int is 0. So 0 less than 5 true. So we can plug this in. And what this means is that the loop will run because this is true. But let's say on the output of the loop, we use the ++ node from actions. There are 2 ++ nodes, so do make sure you're using the one from actions for this. And we put that onto the loop iteration output. So we plug this in here. What this node does is it, using an impulse, it will increment a number, usually by 1. And we can plug this target here into the int. And then what this basically means is each time we go through the loop, increase the value of int over here by 1. So now when I hit pulse, we got output here and an output here, which means that the loop ran successfully, and you'll now see that int over here is 5. That's because what happened is we started it here, it went through once, incremented it, came back through, and it said, hey, is int less than 5? And it was, because it was 1, it went through. Is 2 less than 5? Yes. Is 3 less than 5? Yes. Is 4 less than 5? Yes. Is 5 less than 5? No. And then it stopped, and it outputted a stop. That's all there is to it, really. I haven't seen while used that much in place of for, because I haven't really needed it. Hence why I said I use for a lot more. I use for string matching, for recursive processing of sort of slots or movements, or gameplay resetting mechanics, stuff like that. I haven't really used while before, though. What's common as well is sort of manually setting up a for loop such that you can wait for the end result. I won't cover that in this video because I'm going along enough, but if you've got interest in that one, leave it in the comments and I'll get going on that one and show you what that's doing. I've seen a lot of people that will just manually implement for loops because they want control over when the next iteration starts. That's a perfectly valid thing to do, as for will just try and go through as fast as possible, whereas a manual for loop will wait till you signal it again. I will see you next time. Bye-bye.